is one of those topics that we discuss in the mixed model line design workshop that we just don't have enough time to really explore it in depth. As a matter of fact, we're not even going to scratch the surface on today's webinar. And that's the reason why we have on this topic, just on this topic, an entire 3-day workshop, which is going to be joining our set of live workshops that we teach a few times a year, like mixed model line design, which many of you have attended. And you may recall that lesson 17 is on simulation modeling, but then again, it is really a short lesson. And then we have lean materials management. Again, also a 3-day workshop, and coming in late June 21st, I believe, here in Colorado, we are beginning to teach a 3-day workshop on simulation. And we're very excited about that because it's a topic that really needs a lot more attention than what it's getting normally. So,
okay, yeah, I have some stories to tell about that as well. How I first started getting involved with simulation, but I'll save those stories for a little bit later on. So let's get going, and let's see. We turn this off, and then we turn this.
We go to screen share. So I suppose welcome everybody, and thank you for being here with us today. And we're going to be talking about simulation modeling and the importance of using simulation modeling for your line design. You came to class, or if you haven't yet, you should. And in class, we teach you what we refer to as a static line design. So we calculate number of resources and balancing, all on the basis of static numbers. Then what we're proposing, and what we're going to be making the case for during this short webinar, is on taking the information that you develop during your mixed model line design and putting that or using that as an input for your dynamic simulation model, and in that way you'll be able to get much better information, much more robust line design.
Okay, so let's review what we're going to cover in this. As George said, it's going to be a little bit shorter, I think. Never can tell because we are prone to talking, but here's what we plan to cover in this webinar. So on the left side, we're going to introduce the concept of mixed model simulation for those of you that might be a little bit new to it or kind of have a general sense, but we'll try to clarify what we mean by that. So we'll define what that means, and then why you might be interested in this at a high level, why be interested in simulation, what are the benefits of doing that. And then there are some cases where simulation is pretty much a requirement. In fact, companies we know have basically stated that as a fact, that there are conditions where you really need to. What are you doing?
Nothing. I was just opening the chat box.
Okay. There are conditions where you really need to build a simulation model. There's really no way of getting around it. Now, in terms of mixed model and simulation, we want to dive a little bit deeper into that. And so we've come up with 8 reasons why simulation is necessary for a lean process design or a mixed model process design. There are 8 conditions or 8 things that you want to investigate using simulation modeling. We'll go through each of those. That's really the heart of this simulation webinar. And then there's this issue of, well, how do we actually do this? And this is the exciting part that we're very excited about, that we actually have a way of making it easier for you and for us too to be able to build these models. So we're going to share with you some breakthroughs. I think it's safe to say some breakthroughs in terms of simulation software, because this is a software issue. And then we'll share with you some details of the workshop we have coming up in June 21st, 22nd, 23rd, here in Colorado, in Genesee, Colorado. We'll share with you some of that information. And then we want you to be asking us questions, anything else you want to know about this. Save your questions for the end, please. so we can get through this. But when we get to the end, we'll open it up, and you can enter your questions in the chat box.
Yep.
All right, so let's get going. So what is simulation? Let's talk about that for a minute. Here's a definition. And this really comes back to the older days when we didn't have computers, but we still needed to model things that were very expensive to fix later. And a classic example of this was the wind tunnel. So we have a wind tunnel. The originators of the wind tunnel were actually the Wright brothers. They were the ones that came up with this concept of testing their airfoil designs using a box and using some smoke or a fan and testing it prior to actually building the real thing. And I remember I was telling Gerard, I was in a science fair project in high school where one of my buddies built a wind tunnel as well to do the same thing. And on one end of a box, kind of like a fish tank, he had a vacuum cleaner that was sucking the air on one side, and then on the other side he had his smoke generator. And I'm kind of dating myself when I tell you what the smoke generator was, which would never be allowed today. It was his mother's pack of cigarettes that he'd light and stick in a little hole, and then the vacuum cleaner would suck the cigarette smoke through the wind generator, and of course fill the room then with cigarette smoke. No one seemed to care very much in those days.
In fourth grade,
Yeah.
that's okay.
Yeah, didn't know any better in those days. It was good for you, actually. It was good for us. So what is simulation modeling today? Well, it's a computer-based technique. So we're talking about computers now, and we build a model of a system, and then we run it in compressed time, meaning a day of elapsed time could take as fast as a few seconds to run in a simulation model. And the reason we're doing this is not so that we get an answer. The simulation software doesn't give us an answer necessarily, although there are optimization tools that are available. But primarily we use it to experiment with different scenarios. So we create these scenarios, then we run the model, and we look at what happens. And the idea here is to build a stronger design prior to investing in the actual thing. So designing an airplane or designing a production line, we want to test it as much as possible in a low-cost environment, and that's simulation. So I think all of you got that, right?
And if you think about it, this is perfectly suited for mixed model line design, because we are handling a lot of data, making assumptions as to how the system is going to behave with respect to variability, with respect to balancing, and being able to test that entire day worth of production in just a few seconds is something that, if you can afford it, you should definitely do it.
Okay, now there are some challenges here. It does cost time, and it does cost you some money to develop these models. So we have to acknowledge there are cases where maybe you don't need to do this. But here's a matrix with 4 quadrants that kind of give you an idea of how to assess a project as to whether or not simulation would be highly recommended or good, or maybe optional or not needed at all. So on the far upper right side, you have need to simulate. That's where we have high variability and high interdependency. So variability would be differences in work content times, or just variability in the process itself, or variability in people's work time. So the higher that level of variability, the more important it is to simulate. And then on the x-axis, we have interdependencies. That's interconnected steps that are linked sequentially, that are passed off from one to another. And the more of those you have, just to give you an example, if you have an assembly line with 3 workstations, that's not a big deal. But if you have 30 workstations, those levels of interdependencies and blockages really add up and can really affect your throughput. So the higher you are in both of those dimensions, the more important it is to simulate. So you might have low interdependency, but a lot of variability, again, important to simulate. Or you might have not very much variability. There's usually always some variability, but you have a lot of interdependencies and also a higher need to simulate. So optional might be a small production cell, not very many products, work content pretty similar. You might have less of a need to, won't hurt you, but less of a need to create a simulation model.
A long time ago, I had a line design that was for those natural gas snifflers. You've seen those ones, right? And it was a really small line. It was just 5 sequential workstations. And as we teach you in class, you balance on paper, And then at the end, you balance when live. And that's what we did. We went straight to bringing it live and balance it right there and then when it was live. But it is, what you have to consider is an intermediate step between balancing on paper and balancing when live, and that is balancing with a simulation model. The more interdependencies, products, processes, the more variability, you have to consider simulation as a must.
So here's some other, over on the right side here, some other considerations. So consider building a simulation model if the actual system doesn't exist yet, or it's hard to observe, in the physical world. Or number two, it's too complex to analyze on a spreadsheet. That's mixed model line design in many cases. We start with a spreadsheet, but you may not be able to do this kind of analysis in the static world. Or you have a system, but you can't actually stop it or play with it or physically disrupt it. Impossible to do that, but you could do that in a computer model. Or the system that you're contemplating building is really expensive. And again, some production lines fall in that category, millions of dollars, and you don't want to do it wrong. I remember, just a little case history for you, I worked with a pretty well-known stainless steel sink manufacturer, and they were horrible, really, in terms of lack of flow, a lot of WIP, mountains of inventory, and they rightfully wanted to go to more of a flow manufacturing environment. But the plant manager said, look, I believe this is going to work, but if this doesn't work the way we expect it will, then I'm going to be fired, basically. So I'm going to take part of our budget for this project, and I'm going to build a model of what we're contemplating physically doing before we do it. And so that's what they did, and they confirmed the design, and then the design was physically done, and it was a success. And from that, we saved about 1,000 jobs, by the way. Mm-hmm. This was a factory in North Carolina. But anyway, when you have a major investment, you don't want to get it wrong. And simulation is like an insurance policy. Even if you didn't learn anything from the simulation model, even if you made no improvements, which is highly unlikely, still it might be worth it from an insurance point of view.
Just to know that it works.
Yeah.
Just to know that all your assumptions from your mixed model line design calculations work.
Yeah. And then finally, if you have a lot of variability, you need to account for it in some way or another. And simulation is really the way you would do that. Right. So with that, I think we're sold now, hopefully, on the importance of this. And so let's get into the process of actually building a model. And what we're telling you here is that there is a process, there is a first step that you need to take, and that is building a static mixed model design. So by static, we mean you gather data for a mix and volume of products, and we have work content times that we've documented, and we calculate things like takt time and standard time weighted. These are the things you learn in the mixed model line design class that we teach, the 3-day class. So this is an example of the line design spreadsheet. And if you look down at the next to last row, we have something called a resource calculation. So for every process, then we're calculating how many workstations, how many machines do we need, how many people do we need, based on the math, but that's based on a particular mix and volume of products. And then this is the number of workstations we'd start with in our simulation model. We'd actually have to create a layout as well, so we know what's connected to what. So the good news here, the great news is that the methodology, the static mixed model line design methodology, is a perfect input into simulation modeling, because not only does it give you the layout, gives you the starting point for the number of resources and the work content times that you need. It gives you almost, not everything, but almost everything you would need to build a model. So if you go through the mixed model line design process, you're going to be extremely well positioned to actually build your simulation model. There are a few things that are not incorporated. For example, some estimate of variability may not be in the static design, but I would say 95% there in terms of the data you're going to need to build the model.
And why would you go any other way? You learn mixed model line design, and rather than guessing or pulling numbers out of the blue sky and introducing those into a simulation model, you want to go through the roadmap, do your resource calculations, do your balancing on paper, and that will be a much more solid model for you to improve.
All right. So here are the 8 reasons then why we might consider simulation to be necessary. And this is all related to mixed model line design. So the first one is be able to plan for process variability. So process variability is just, you might call it human variability, or it could be machine variability, but differences from the standard time that occur. In your static design, you have a time that you use to calculate the weighted time, but is that time always that time? Well, if it's people we're talking about, the chances are great that it's not. If you have a standard time of 10 minutes, does it always take 10 minutes to do that work? Chances are good that it doesn't. Sometimes people work a little faster, sometimes people work a little slower, and this can vary by person, and it can also vary by time of day. Could be in the morning, people are all fired up and fresh. By the end of the day, they're dragging.
And then again, you may be an industrial engineer and account for all the allowances. And you're correct. If you account for all the allowances, you will come up with the right number of resources. But the number of resources is just a starting point. After that, there is the balancing. How many process Kanbans do you need? How are you going to position those? And it will be simulation what will put you in the best position to make that decision. So process variability, understanding the statistical nature of work content times, especially when humans are involved, is very important. Only simulation modeling can help you with that. So if there is any variability, and if there is a lot of variability, you must simulate.
Okay, the second variability that we need to think about, and that's pretty much inherent to the mixed model environment, is differences in work content time by product. And there's no way to really get around that or level that across products. It is what it is. It's the work content for each individual product. And if you have a family of products, then most likely you have a range of work content times, and you're never going to be able to get rid of that. You can do your best to level load it, but it's always going to be there.
And of course, in the mixed model line design roadmap, we take care of this by calculating a weighted average standard time, but then again, it's an average. And an average will get you the right resource calculation. Sometimes you will have to make some allowances and increase the number of resources. And this is something that simulation modeling can be extremely helpful, because again, you may have a very good resource calculation based on an average, but then you test it for certain mixes and you realize that a mix that you see 2, 3, 4 times a month won't be able to go through your calculated number of resources, and then you can change that, retest the model, you get better answers, you have a more solid, more reliable line design.
Okay, next one, simulation regarding optional processes. So an optional process is a process that you don't need all the time. So the challenge there is you can design it for a given percentage, optional percentage, but in the real world, that percentage is going to vary. So you really want to be able to test the impact of that. Otherwise, what can happen, and this has happened more than once, is that optional process becomes a bottleneck under certain conditions. So you certainly want to be able to test for that and see what the right level of resource is for that optional process.
And as you may recall, we talk about this in class. We spend a good amount of time talking about optional processes and all the different strategies to deal with our optional processes. As a matter of fact, this topic is so important that we have a graduate level webinar, 90 minutes, just talking about optional processes. And after applying all those strategies, simulating that will allow you to test one strategy versus another one, which one to emphasize, which one to de-emphasize. Should I oversize the process? Should I add IPKs? Should I put in place a FIFO lane? All those you can test. After you make the decision, you're going to recalculate, then you can test with a simulation model.
All right, number 4, optimizing buffers, so IPKs. Those of you that have been to our class, our mixed model line design class, may remember us saying on more than one occasion, well, when the question comes up, how many IPKs or buffers do we need? Our answer is, well, in lack of other information, the answer is one piece. Now that can vary if you have a very large product or if you have very long takt time. Those are 2 exceptions. But the thing is, it's just a rule of thumb. And how do you actually test the optimum number of buffers? We know from experience that the law of diminishing returns hits pretty quickly when we talk about adding more buffers hoping to improve performance. But the beauty of the simulation model is it lets you try it out. What actually happens when we add 2 IPKs or 3 IPKs? Does that actually improve performance or not? And really set the correct buffer level in your line design in a more scientific way, rather than simply using a rule of thumb.
And we know from experience that in a very short takt time environment, more than 1 IPK is normally necessary. And we have run simulation models in which we see you put 1 IPK, performance is X. You put 2 IPKs, performance goes up by 25% immediately. You put 3 IPKs, performance doesn't improve at all. So then you know you don't need 3 IPKs, 2 will do.
Yeah, so this really, using a simulation model really answers the question, how many IPKs? Because you can try things out and choose the best number. All right, number 5, what do we have here? Sequencing rules. So in a mixed model environment, sequencing, that's the order of your production plan, the order in which you build products is critical. It's a requirement. But again, the same question as with buffers comes up. How do we develop our sequencing rules other than tribal knowledge or other than just kind of intuition? Well, the simulation model lets you experiment with a variety of mixes of product and allows you to actually create or develop your sequencing rules.
Should we go by work content, long, short, long, short, long, short? Or should we go 2 shorts followed by 1 long? Do we have that? Should we go by, what happens if we sequence by color? What happens if we sequence by truckload or by customer order? All those you can test using simulation model.
Yeah, if we have changeovers, for example.
Exactly.
You can do a static analysis, same as with your mixed model line design, but you can also do a simulation of different batch sizes and take a look at how that impacts performance. So that's a great use.
And then again, where you start with what we taught you in class.
All right. So flexing rules. Flexing is something that we teach. It may be new to some of you, even the term. By flexing, we mean the ability and willingness of workers to move in the production line to where the work needs to get done or move to the bottleneck. So typically that means an operator will have a primary station and then be able to move one up, 1 down, 2 up, 2 down in that production line. So in a zone. Now, why are we interested in this? Flexing has the potential, and again, we have a graduate course in this. Flexing has the potential for huge, or as Donald Trump would say, huge productivity gains. Because if you have a person at every workstation and they're blocked and they have to wait, which is, as you can appreciate, not uncommon, then your productivity is lost for that period of time.
That time, you never get it back.
But if they can move to another station where work is available and continue adding value, then your productivity just took a big jump up.
There is a continuous self-balancing effect. Again, we would never say it's a balancing tool, but it has a very strong balancing effect, and the productivity improvements can really be very substantial. We are always very conservative with that prediction of productivity improvements, but we have seen up to 30% productivity improvements just from flexing. And if you want to be conservative, plan on 10, 15%, and you will see some much better resource utilization.
Yeah, so this is a great use as well. Okay, number 7, resource calculation validation. So you've done a calculation already, a static calculation of the number of workstations, number of people, number of machines. Now, when you add variability and product variability and process variability, is that still the right number, or do you need to round up or increase slightly? That could very well happen. But you're not going to know how much to add until you do this analysis, right?
It allows you to do a sensitivity analysis. How would our line react to this mix? Remember, we insist on this in class many times. We're designing a mixed model line on the basis of an assumption of mix and volume. That is your forecast daily volume. From there, do you think customers are going to order based on that? Of course not. They're going to give you whatever they give you. So you can take 2, 3, 5 bad days from the past and see what they do to the line with a simulation model. With that, you can tweak your resource calculations or validate them.
Yep. And lastly, testing Kaizen projects. This is another good one. This is a slightly new topic, but the question here is if you have a proposed improvement or Kaizen project, process improvement project, How do you know what to expect? You hope in most cases that you're going to see some benefits from that kind of effort, that kind of improvement. But if you have a model of your production environment, your line, you can actually incorporate the proposed change into the model and test the results and see what you can expect. So this can be, again, huge opportunity for process improvement once the line's already in place.
I remember a story that Richard tells every now and again from a client where the CEO called us and said, listen, we've been at it for quite some time with this lean stuff. And this year we had 250 Kaizens. And I do not see an impact at the end of the line. We're not shipping any more product is not any better. What's going on? Well, the fact that you're improving something doesn't mean it's going to impact the line. You may be improving something somewhere else. Where are you going to see the results? If the focus is on improving flow, then here is a project. You can test the impact of that project on the flow of product. Then you can decide on the priority of that project. Not suggesting here you kill the project. It just becomes a question of priority and how you allocate the resources for those projects.
All right, so hopefully you're sold now, right? You're fully convinced that this is a good thing, important. So let's kind of take it to the next step. Next step is, well, how would we do this? How would you develop a simulation project? So here's a quick summary at a high level of the steps involved. So step number one, you need to have a design. And it's going to be a static design based on mixed model line design principles. That's what we've been calling a static design. So that's our foundation, that's our starting point. Second step is, before you need to build a model, there's some basic things you need to do with that. Make sure that from that data that you're using, you've eliminated waste by reducing the process variability to a minimum. You know that process variability is going to be negative in terms of your simulation results. And the primary way to reduce process variability in the lean world is through what we call standard work. So standard work definitions and training people to do that work the same way. So the one best way to do the work and train people to do that. That's the most important step here. So if you haven't done that, then that's a good starting point. Next thing, plan to use buffers, in-process Kanbans. Pretty much you know that those are going to be a requirement. So include those in your design. And that's especially important if you have potential bottlenecks where a feeder line connects to a downstream process, to buffer that, right? To have one or more IPKs there. And now we're ready to build a simulation model. As we said before, most of the data is already available to you. And we'll talk about how to actually build that model from a software point of view in just a second. But use the simulation modeling, and you want to test a variety of scenarios, of realistic scenarios of mix and volume based on what you've seen in the past, based on what you anticipate in the future. You know that mix and volume is going to change, so test within the range of reasonability a variety of mixes and volumes and look at what happens. Look at your throughput, look at your productivity, look at the utilization of machines and people, and run a variety of scenarios and make improvements. Now, how do you make improvements? Well, we have what are called the balancing tools. Again, the balancing tools of mixed model line design, you can apply them in the order in which we teach them, starting with eliminating waste and going on to relocating work and going on to adding additional buffers and going on to adding additional resources or adding time plus inventory. So you apply those to improve your design. And again, incorporate it into the model, see what happens. And number 6 is you can count on sequencing being a requirement or being important. So developing your sequencing rules and coming up with the right, it's not just the daily volume, but it's the order in which you build those products during the day that's going to have a big impact on your throughput.
It would not be a good use of resources to think that you will design a line at which you can just throw orders at and then just see what happens. You need to figure out those sequencing rules. Are you going to sequence by work content, by color, by customer order, by full truck, and then build those rules and test them? So you really have to consider the sequencing is going to be a requirement.
Okay, so let's get on with it here and share with you how you might actually learn this stuff in much more detail and then be able to apply it. So we have a workshop. We're very excited about this. This is the first time we've done this. And let me give you a little background on this. Both Jordan and I worked for a company here in Colorado, a lean consulting company, for quite a few years. And then we went our own ways. And the company that I worked for after I left this consulting company, lean consulting company, was a simulation company in California. And my thinking was kind of as follows. Back at our prior company, we were mostly successful. Gerard and I were always successful, right, Gerard?
No, absolutely.
Yeah, we never had any failures,
failed.
but we heard
We heard
that
of others.
others that had struggles with projects. And in retrospect, those difficulties, or I don't know if I can call them failures, but difficulties,
Challenges.
yeah,
I like challenges.
yeah, could have been avoided if we'd known more about the simulation modeling thing, because it really came down to a lack of understanding of the flow and how things were going to interact, and we didn't have the tools, and then the results were what were expected.
Yeah.
And so, if we'd had simulation tools at that time, we could have avoided some of these issues that we ran into, or that other people ran into, and that we had to try to help them on. So I joined a simulation company called Karan Consulting Group in California. They were the California reps for one of the major simulation software companies, but they were also industrial engineers. And so they did a lot of these lean projects for companies like Columbia Sportswear, Toyota, automotive, all the big automotive companies. So they were doing a lot of really challenging and large simulation projects. And my thinking was, gee, this is something, as a lean person, this is something I need to know, right? Add it to my toolkit. Well, I still believe that, but what happened actually was I realized simulation, to become a simulation expert and deal with highly complex models, you really have to become a
professional on that. Yeah, you have to be a pro. You cannot build simulation models on your spare time unless they're very simple.
Yeah, it's a little bit, it would have been a little bit like me thinking, gee, I really like computer programming, so I'm going to continue my regular career, but in my spare time in the evenings, I'm going to read a book on C++ and become a really good programmer. That's just not going to happen. You really have to put in your 10,000 hours, I think. But there is room for people like you and me. Those of you listening, I'm kind of presuming, but for us to be active participants and users of simulation modeling. And so that's really the focus of this class. How do you build models? How do you interpret the results? How do you use simulation to improve a process? That's really what we want to focus on.
How do you become a good user of simulation?
Right. Not so much how do you become a software guru in terms of building simulation models. Now, I don't want to discourage anyone from pursuing that. Oh, it's great. But that's not necessarily, that you have to recognize that's going to be a major undertaking for most of us, unless you're a complete genius.
Yeah. One of our clients in Florida, they have lots of small cells building medical products. Well, then I would definitely encourage their lean group, all the members of the lean group, to learn simulation modeling and to actually build their own simulation models, because their cells are what, 4 or 5 workstations, right? Yeah. With a couple of people, those definitely you can build those and then interpret results. So this class, we want to focus on making you a good user of simulation modeling.
Yeah, so to continue my story, I stayed with the simulation company for a couple of years. I really appreciated the kind of questions that you have to ask if you're trying to build a model that you expect to actually represent reality. Is at a normally deeper level than we're used to, and they were really good at that, of interviewing clients and really drilling down deep in terms of what's going on with this process, especially understanding the variability and those kind of impacts, because I knew it was going to affect the model. So I left them. Gerard and I formed the Leonardo group, but in the back of my mind, simulation's great, just didn't have the software or skills to make it a reality. Mm-hmm. Then, a few years ago, we had a large project and the customer required simulation modeling, rightfully so, smartly asked for this. And so I went back to this company that I worked for and asked them to submit a proposal to be the simulation modeling partner on this project. And they came back with an interesting idea. He said, I've been I've been working on this is the head of this company now, I've been working on a simulation engine built in Excel and Visual Basic. And I think this would be a good opportunity because it's going to be easier for the client to understand the data. It's going to be much faster to build these models. Now, this engine, the simulation engine, is an actual discrete event dynamic simulation model. It's not a Monte Carlo simulation or anything like that. It's an actual, engine that's going to take data and process it in a discrete event kind of way, the way that any commercial software would. But it doesn't do everything for everyone. It's designed for production lines, basically, for flow processes. But I think it would be a great application here. So we went back to the customers, suggested this approach, and the answer was yes. And so we did that. And we had a very successful simulation project using this Excel-based tool. So then after the project was over, I talked to Jalal, who's the developer, and I said, Jalal, what are we going to do with this? Because we have this engine now, and it's not being used for anything. It's, we're not selling it, and what are your thoughts? And he said, well, I'd like to make some use of it, but I'm concerned because I'm not, I don't want to start a software company, so I have the software developed, but I don't want to have to get into that world. So we'll have to put this on ice for a minute and think for a while. So we did nothing with it for a year or more. And then about 6 months ago, I called him back, let him think about it. And I said, look, here's an idea. Let's share the software. Let's give it away for free. As long as students understand it's a teaching tool.
And it's not a commercial product.
Not a commercial product, right?
You're not going to be able to call 1-800-HELP-ME.
Right.
No helpline.
But let's just give it away. And let's build a course around it with your expertise and our lean expertise, our expertise in mixed model line design, your expertise in simulation modeling and interpreting results. And let's really gear this class to give people some tools, but also train them into how to be an effective partner in a simulation project so that they understand what data is going to be needed. And more importantly, they understand how to interpret these simulation results that come out, because it can be a mass of data, right? That needs to be understood, that they can use for process improvement. So with that, he got excited, we're excited, and we're proceeding forward.
So if you came to the mixed model line design class, you may remember that during the class, we give you a set of hands-on exercises for a bicycle factory. We're going to take that bicycle factory. We're going to work with you to have you build the simulation model for that bicycle factory, and then we'll spend time with you helping you interpret the results from several runs. This class is going to be a lot lighter on the lecture part. So this is going to be, what would you say, Richard? Around 50% is going to be hands-on.
Yeah, hands-on.
Working
with
teams. Exactly, working with the model.
And working on your laptop with the software we'll give you, which you get to keep. You get to go home with it.
You'll take it home.
And remember, I'm not saying this is toy software. This is software used to develop major production lines at a big multinational company. But again, there is that proviso that it's not commercial.
It's no commercial software. So
yeah.
No helpline.
Yeah. That's not to say you can't ask questions about it or send emails, but generally speaking, that's the condition under which Jalal is allowing us to use it.
To share it.
Yeah. So our first shot at this class on June 21st is going to be in actually a town called Genesee. So it's in the foothills outside of Denver. Yeah. It's not a huge drive, but beautiful site.
We also
up a little bit higher.
Absolutely stunningly beautiful site for you to go and enjoy. We're going to be providing lunch and all the meals, and you're going to absolutely love this place. Yeah.
And you're going to have your laptop with you. You're going to load the software, and then we're going to talk about a concept or talk about a data element. You're going to do it. So a lot of hands-on exercise. And the idea here is to be able to go back to your company with a really solid foundation as a lean, as a knowledgeable lean simulation person. But you might still need some expertise in terms of model building later on, depending on what it is you're trying to do.
And depends on the level of complexity. Some of the folks that were in class last week, they had line designs that were simple enough from the point of view of the number of interdependencies, but complex enough on the variability that I strongly recommended to them, you have to simulate. You have to simulate. And I think we're going to see them in June, because for them it's mandatory, but they can build their own models using the software.
Now, we've also been in touch with some commercial software, simulation software companies, and they have some interesting offers for you that you'll be able to take advantage of. Some of you may have companies that already have an approved simulation software tool that you use, software system. Some of you may not, and so we have some interesting opportunities in that regard from actual commercial, leading commercial simulation software companies that we'll share with you. All right, so let me show you what this tool looks like a little bit. Workshop topics. Let's do that first. So very quickly, what are we talking about in this 3-day workshop? Well, we're going to review quickly the methodology for the static line design. We're going to assume that you already have some of this background.
Yeah, you read the book, you came to class, so what we teach in 3 days, we're going to be done with that in the morning. So 4 hours and that's done.
Right, so mixed model line design, static design on steroids, but we'll get through that. We're going to map the data that you're going to developing a static design to the needs of simulation modeling, so we're 100% clear on that. And then we're going to get our hands on the keyboard right away and start building models step by step, showing you how to enter the data and then how to run the models and then how to use it to do these various things that we just talked about, the eight opportunities, right, to test your model vis-a-vis process variability, product variability, feeder lines, etc. And basically, you're going to be spending a good part of your time running models and creating experiments. So you get a really good sense of how you develop sequencing rules, how you optimize buffer sizes, how you actually use a model to do all these things.
And every team will get a chance to present their findings after each round of simulation.
Yeah, a little bit of competition there.
Oh, yeah.
And then flexing, how to use some simulation modeling to test the benefits of flexing. And this kind of knowledge that you'll be gaining will apply to any simulation software package. So it's simulation software neutral from the point of view that they all work pretty much the same way, and whatever simulation software you're using, you're going to be looking at the same type of output.
Yeah, the only thing that's different about ours is how you build the model. After that, how it runs and the result it gives, it'll be the same if you use Pro Model, Simulate, or SimFactory, any of those.
Yeah, and then we'll be spending some time not just on a mixed model line design, but also on some of the variants of that, production cells, optimizing feeder processes, even often office value streams. Mm-hmm. Talk about how you might use simulation for that as well. So it's going to be great. I think it's going to be fantastic. Yeah. It's going to be the best. So here's a screenshot of the simulation tool. What you're looking at here is the actual running of a model, and it has some simple animation, meaning you don't see little people or machines running around on the screen, but you do have for each resource a kind of a status, color-coded status block that you might see here under station 1, 2, and 3, and 4. See it as fin 1, fin 2, fin 3. It might be kind of small on your screen, but those little boxes will change color depending on what's happening at this particular moment in time while you're running the model. So you build the model, and then you come to this screen and you create a JPEG, an image of your line. You can populate it with these little status lights, and then you run the model.
In the graphic part of a simulation, it sounds great, but after you run the simulation a couple of times, you really want the results quickly. So even if you have a $20,000 piece of software, you will turn off the animation because you want to see the results quickly.
Yeah, the joke is building a complex 3D model where you can see little people walking around. Mainly you do that to sell the concept to management.
Yeah. After that, you want the results quickly.
Yeah. And you'll notice a button here that says disable animation. So you can turn this animation on and off. And once you get the hang of it, you're going to want to turn it off because it runs about 10 times faster than having to update all these lights and things. So this is the running screen. And then let me just give you a quick overview of the data entry portion of it. This is actually in a separate Excel file, the data file. And if you look at the tabs on the bottom in yellow, we have a number of different tabs that you'd fill out. And the really unique thing about this particular tool is the learning curve for you is going to be short. We considered using commercial software for this class, but the learning curve on any of them is going to be a showstopper.
Yeah, it would have taken us 80% of the time just to teach you how to enter data, and no point in that. Everybody knows how to use Excel, right? If you know how to use Excel, we can teach you how to enter data.
So the great beauty of this is by entering the data correctly, but it's pretty intuitive. You're actually building the model at the same time. So you're killing two birds with one stone, pardon the expression. So down at the bottom, we have flow description. That's the routings you're going to have to define. And then resources, that's the one we see here. So we have 4 workstations and 4 operators. And then you define the flow. That's again, the detailed routing, what's connected to what, in what order. And then we have a product list, and then we have process times, so work content times, and then we have a sequence, which is your order of production.
See, this is all this maps very closely to what the data we told you need to gather during the mixed model line design class. It maps exactly.
Yeah, so this is a lot of fun. It doesn't take long to learn, and the beauty here again is that we're going to get to running these models very quickly in this workshop and not spend a lot of time having to learn software. Some little explanation along the way. So that takes us to the end of this kind of explanation.
Yeah.
But we wanted to open it up for you all to see if you have any questions that we can answer about this.
Well, and also we said it wasn't going to take an hour, and we're almost there. So
yeah,
when they give us a chance, we just talk, don't we?
We just talk. Okay, so Ashok has a question here. Does resource calculation validation, that was one of the 8 benefits, using simulation mean that standard work playbook can be generated based on variation in customer demand? I don't think so, if I understand that question right.
Standard work playbook, that is
standard work definition, standard work playbook.
Yeah, I think he's referring to graphic work instructions, the work instructions, right? That is, if I remember, Ashok, last week you were talking about that playbook as the work instructions. Customer demand has no impact on that. Should have no impact on that. The work is the work, right? And the validation refers to those resources you calculated last week. If you say you need 7 workstations to assemble the bicycles, do you need 7? Or may you need 8, depending on how the orders are sequenced. That is what you're looking to do with the validation, with the model and the validation portion.
Okay, if that answered your question, let us know. Or
if not, we'll take another crack.
Yeah, ask again in different words. Okay,
oh,
Bruce.
Hey, the one at the bottom. I'm doing well, thank you.
Oh, Shakir. Gerard's doing well. I'm doing well too, thanks. Okay, Bruce. Is mixed model line design class a prerequisite for attending this class? It's not a hard prerequisite, but what we're going to do is try to get you pre-educated.
Yeah, if you plan to attend the class because you're interested in being a good user of simulation and you have not attended our mixed model line design class, let us know. We'll get you a copy of the book. We'll get you studying. So when you come to class and we say standard work definition or standard times, or work content times, or resource calculations, or we talk about the different balancing tools, we're all speaking from the same book. So we'll get you a copy of the book. So again, the answer is, it's not a hard, as Richard was saying, not a hard prerequisite, but we need to make sure you understand mixed model line design.
Yeah, we have a book, The Complete Guide to Mixed Model Line Design. Yeah, and so at a minimum, probably go through that and educate yourself a little bit.
If you sign up, tell you what, if you sign up, we'll send you a copy.
Okay, Dan, is flexing kind of similar to operators moving within work cells? Yes?
Yes. It is moving. However, it's not walking around looking for stuff to do. It is based on a set of rules that we teach in class, and that we have an entire 90-minute graduate level webinar on that because it's so important.
Yeah, and this
is
kind of
moving.
Yeah, and it's kind of it's kind of I don't know if I should say this, but it's kind of an anti-Toyota kind of concept. In the Toyota production system, they put a lot of emphasis on level loading.
Yeah.
And the idea of having more workstations than people is kind of a heresy a little bit. It would be viewed as kind of a waste, right? But that variability that you encounter is never going to go away, no matter how hard you try to level load.
But they don't see that variability because it's so level loaded. I mean, they live and die by it. And if you have a 6-week planning horizon, yeah, you can probably get away with that. But for the majority of us mortals that we have to deal with great variability, having a line with more workstations than people is pretty much a prerequisite. You have to consider flexing. If not, you're going to be leaving money on the table. Can you bring a line live without flexing? Absolutely. Can you run without flexing? Absolutely. You're just leaving money on the table.
Okay. So we have ASHOC has a clarification.
Yeah.
Playbook is standard work definition based on min, max, and median tack time. Duh.
No. When we talk about, let's separate. Standard work is standard work. And I know some folks out there say that standard work is affected by tack time. No, it's not. Tack time is calculated. Standard work is measured with a stopwatch. So now, does min, max, and median should be accounted for in your standard work? Absolutely. But in will that come into play in simulation? Yeah, but you will using statistical tools, you will come up with a single time, then apply a statistical distribution around it. When you don't know any better, you will use a triangular distribution around your median time. But TAC has nothing to do with this.
Right. Okay, Ashok, I hope that's still clear, but
Yeah.
keep on trying. Dan says the Excel simulation software can be used in service industries. Sure.
Yeah.
It doesn't know. It doesn't
Yeah.
know what you're modeling.
It doesn't know. Absolutely.
Now, one proviso: it's really designed for a flow kind of environment.
Yeah.
So it's looking for sequential processes or steps
Yeah.
or workstations.
Yeah.
And it's going to be less useful when you have kind of a bowl of spaghetti kind of scenario.
Yeah.
That's where a commercial software would.
Or maybe it can do it. We just don't have the knowledge to make it.
Yeah, we've never tried actually. Never tried to do it, but
yeah, as long as you can define the work, you can define the processes. You have products, and in service, product can be a credit application. It could be a processing an order. It could be processing a truck design in a boom truck factory. As long as you can identify those individual service units, right? In a pharmacy, it's going to be the individual prescription. As long as you can identify the service units, you'll be okay.
All right, should we go back? Let's go back. Here we are.
Okay.
All right, we are here. We're still
Here we are.
Yeah, instead of looking at that screen. Okay.
So look forward to seeing you all in June. That class is filling up pretty quickly. So if you're considering it, please click. I think we have the address there. Go to LeonardoGroupAmericas.com and you'll be able to sign up for the class. And we look forward to seeing you all. By the way, Colorado is going to be absolutely beautiful.
Yeah, in fact, I think I mentioned in an email, an option for you is come to the class and then stay for the weekend.
You sure?
You'll be on the road. You'll be just off of I-70 on the road to Vail and Beaver Creek. And
actually, from
Breckenridge.
there on the last day, come in with your suitcase, and from there, what would you have? An hour?
An hour to Vail, I think.
Yeah, hour to Vail, and
Yeah.
you can spend the weekend.
Yeah.
Look forward to seeing you all. Thank you for the questions, and stay in touch. And please remember to give us your suggestions for future webinars. And we will continue do our graduate level webinars to expand on topics that in class we can only talk about them for 15-20 minutes, but we can give it 90 minutes here, and really expand. Right now we have done, what, half a dozen? And we have a few more, so maybe 10, and we're planning to do around 20 some of those a year. So please keep the information coming. We look forward to hearing from you.
Okay, we're letting you go about 3 minutes early.
Okay, excellent. Thank you all. Have a good lunch, and we'll be in touch. Bye.